Once again, on the internet, we aggregate the routers in a region and call it the autonomous system, an AS. Or sometimes we also call it a domain. So the internet is a network of ASs, a network of domains. The routing protocol within the AS, the network admin configuring all the routers running, is called the intra-AS routing. So you see here, it's the routing protocol running among all the hosts and routers in the same AS. All routers in the same AS will need to run the same intra-AS protocol. Now, routers belonging to different ASs can then run different intra-AS protocol. That is an independent, autonomous choice of the network admins individually. Now, each AS will also pick powerful routers, usually sitting at the border of the AS. These powerful routers, I called them the delegate routers earlier. Yeah, here you see a more formal way of calling them are the gateway routers. So gateway is what? The doorway. Yeah, the router sitting at the border of these AS connecting to another AS. Okay, so gateway routers, powerful delegate routers, will be sitting at the edge, the border, of its own AS, and have links both within towards routers within the AS and links to routers in other AS. And therefore, this routing protocol, in running in the backbone of the internet, is called the inter-AS routing. Okay, so that is the routing protocol that's running across the gateway routers. So this is the routing, working among the ASs, and the gateway router there will be doing the inter-AS routing computation. And on the slide here, you see an example of ASs and how ASs interconnect. So we do have 3 ASs, 1 here, 2 here, and 3 here. You see individual routers interconnected within one AS. Okay, so there are 3 here for AS2 and 3 more here for AS3. Now, AS1, 2, 3 each could run its own intra-AS routing, but you see 1B and 1C, both of these routers have links internally as well as externally. So 1B and 1C are the gateway routers. So these 2 gateway routers. Just like 2A for AS2 is one of the gateway routers. 3A for AS3 is one of the gateway routers. And inter-AS routing is running in between. 1B, 2A, 1C, 3A, and so on and so forth. Now, the focus of this slide is to talk about how would the forwarding table look like when we have 2 levels of routing running on the internet. Now, let me show you an example here. 1D is one of the routers existing on the internet. What's going to happen there is the forwarding table is not going to be just contributed from the intra-AS routing algorithm. It would also be contributed from the inter-AS routing algorithm. As you see earlier, in order to pass data from one router to another router that's far away, not within the region, right? You need intra-AS routing to find the gateway router. And you also need the gateway router to find, hey, where's the destination gateway router? All right, so you do need inter-AS routing algorithm telling each node where to pass data further, just like you need intra-AS routing there telling you how to reach another router within the AS. So forwarding table here will be configured by both intra and inter-AS routing algorithm. The intra-AS routing determines the entries for destinations within the AS, within AS. And inter-AS determines entry for the external destinations. To be precise, the inter-AS determines which gateway, which router here you should be passing the data to. But intra-AS will also be telling 1D here Okay, to go to that particular gateway router, what is the right way? So you see here, interplay of inter-AS and intra-AS routing for packets going outside of the AS. To make sure the interplay of the intra-AS and inter-AS routing is more clear, okay, let's take a step back. Okay. Look at AS1 here, 1A, 1B, 1C, and 1D. Okay, so these routers within AS will run the intra-AS routing. Therefore, they will know the shortest path going to each other. No problem. Now, at the higher level, at the inter-AS routing level, so we have these gateway routers. 1C and 1B are the gateway routers of AS1. 3A obviously a gateway router for AS3. But you see here, 3B having also connectivity to outside to another AS. 3B is also a gateway router for AS3. Similarly, 2A, 2B, 2C all have links to outside to other ASs. So they are also gateway routers. So these gateway routers at the higher level will be running the inter-AS routing, so that's another routing protocol, and they will all be running the same routing protocol. They will exchange information to each other using the link state or the distance vector routing to come up with the shortest path. But this time, the shortest path is what? Oh, if I want to go from AS1 to AS2, the shortest path is to go directly from AS1 to AS2. Now, if there is another AS here, AS4, for example, okay, then the shortest path might be to go from AS1, AS2, and then AS4. Okay. So these gateway routers will maintain shortest path, but shortest path in terms of, what is the next AS to the destination AS? What is the next AS to the destination network? So we might have another AS here, AS5. Then the shortest path from AS1 will be what? AS1, AS3, and then AS5. Okay. With those said, we may now walk through the scenario here. Let's suppose a router in AS1, say 1D, and it's got packets to go outside of the AS. Let's say AS5 here. Now, we see the shortest AS path will be the what? A1, AS3, and then AS5. And this information will be available here at the gateway router. 1C, 1B, 3A, 3B. But 1D here as an internal router. So this router here, we'll have actually trouble judging, right? Among the two gateway routers, 1C and 1B, which one of these 1D should be passing the packets to, so that these gateway routers will be able to pass further to the neighboring router along the shortest path to the destination. This is also saying, even though these routers are internal, they participate in intra-AS routing. They do not participate in inter-AS routing, but they need still to know the shortest AS path to these destination ASs out in the world. Okay. So 1D, 1A don't do inter-AS routing, but they still need to know the inter-AS path. Okay. So they must learn the inter-AS path, which is to know for each destination AS, is it AS2 or AS3 being the next hop AS to the destination AS? And this is essentially the inter-AS routes. And how? Okay, how does 1D and 1A learn? Well, you know what? 1C and 1B do participate in inter-AS routing. So 1C and 1B thereafter, inter-AS routing will then propagate these AS path information to all routers inside AS1. Okay. And so propagation of the AS path, just like computation of the inter-AS path, would also be part of the job of the inter-AS routing.